Hello, welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today we have Robert Balicki. Did I say that right?
That is correct.
He's the creator of Isograph. Right. Welcome, Robert. How are you?
Awesome. Really, really happy to be here. Really excited to be on the podcast. So, yeah.
So we are recording the podcast in person, which is the first, I think. Oh, no, actually, this is not necessarily the first, right? As I said before, we recorded episodes in person at Rust Nation. And now we're recording in Hong Kong because you're here visiting in Hong Kong, just so happened to be.
Yep. Bustling Hong Kong, one of my favorite places in the world.
Well, it's good that you can come to Hong Kong on a visit, right?
Mm-hmm.
So it's not often we get visitors over here. Everybody likes to go to Singapore, China.
Yeah.
Not really too much to Hong Kong these days.
Yeah. I prefer Hong Kong. It's bustling. It's fun. There's just like so much energy here. So I like it here.
It's good to hear. But you've come here. You've messaged me over Meetup, and you're actually going to present on Monday about Isograph. And I thought since you're here, we're in person, we can also do a podcast recording.
Yeah, I love it. 2 for 1.
Yeah, so might as well make the best use of your time and of your trip. So Isograph, right? If you think and look up Isograph in your presentation, it's all about front end, right? And of course you can use Rust in the front end, but you're talking about using React and I think JavaScript, of course, TypeScript, definitely. So how does this all fit in, right? I think maybe you can give more of an introduction about what is Isograph and then why is it related to Rust, maybe?
Yeah, sure. So Isograph is a framework for building React apps that are powered by GraphQL data, but has ambitions to be a framework for building apps that are powered by data. It gets a lot of its really advantageous properties by taking advantage of a compiler that's written in Rust. So it takes advantage of a lot of generated files and a lot of sort of static analysis. All of that stuff is done in Rust, and then it generates a bunch of files that are then used by the Isograph runtime, which runs in the browser, to give you the experience that you want. So in the long run, JavaScript, React, GraphQL, those are all going to be implementation details. Right now, they're the only way you can use Isograph, but there should be no reason that you can't build, let's say, Swift apps using Isograph, or Kotlin apps, or apps that instead of using GraphQL as a language to speak to the server that generate SQL, or build Svelte apps, or build Angular apps using Isograph. But all in due time. For now, the first target is React, GraphQL, and JavaScript.
So you have a pretty long roadmap, right?
Oh, yeah.
Okay, it's getting pretty interesting. That's a lot of work, right? You open source this so that everybody can help you, or?
Yeah. It's fully open source. I have one other guy that's helping me out on this right now, Edmondo. He's shipped some awesome features. And now is honestly a great time to get started contributing to the Isograph project. There's a lot of sort of foundational work to do, but there's also, I think, a fairly well thought out roadmap. So if you want to be able to do sort of foundational work where you know exactly what you're going to do, but it's still a big project, like now's a great time to join. Some of the big things that we need to do in Isograph include targeting other languages, include getting all of the features that Relay, which is another framework for building React apps that are powered by GraphQL data, getting all of the features that Relay has into Isograph, because Isograph under the hood has a lot in common with Relay. I was also previously on the Relay team at Meta, and then there's a lot of innovation in terms of the language that you write. The experience of using Isograph, so taking a step back, is that in your components, you specify what data those components need. So for example, a blog post might select the blog name, blog author, and blog content for a blog post component. And then when you save that file, the compiler will scan it. We'll see that, hey, there's what's called an Isograph literal in this component. And it will say, given that I've encountered this literal, I need to generate this file. And if you also separately have what's called an entry point for, let's say, like the blog detail page, which references a bunch of components, then the Isograph compiler will generate a single query for that entire blog page. And then that file, the query file plus like the file for the blog post subcomponent, will be used by the runtime to, one, make a network request and write that data back into the sort of the front end store, and secondly, to read out the data that just that blog component needs. So in combination, you make use of the fact that we have a compiler that generates a bunch of files, and then that gives you like this really, really good developer experience where it's very easy to, for example, just reason locally about one component at a time. So you look at the blog post component, you say, I need the name, author field, whatever. You're using those in that same file, easy to check. You can make whatever changes you want. And then the query is always sort of up to date. So that means that if you come back to this blog detail page and you realize, oh, we don't no longer need to show this field, like the copyright year field, okay. You can remove it from whatever component is rendering it, and you can feel safe doing that. The alternative in a world where you're manually writing queries is you remove the field from the subcomponent, and you go to the query declaration and you think, can I remove the copyright year from the query? And the answer is maybe, maybe not. It really depends on what all the other components are doing. And there's no way to safely remove that field without risking breaking your app in some way. So the fact that there's a compile step that takes all of the data dependencies that each of these subcomponents have and stitches them together into a single query is what gives apps built with Isograph a level of stability that you can't get when you're just manually writing queries. Now, that's not the only alternative, of course. Alternatively, what you could do is structure your app such that every single component fetches its own data. And that's great in terms of stability because you can reason locally about a single file. And as long as it selects all the fields that it will use, the app will continue to work. But that comes at a cost. Every component is fetching its own data, so you have a lot of redundant network requests, and the fields you select from the database are selected redundantly, so you're grabbing the same data out of the database multiple times. And even worse, if you have an outer component that fetches data, its network request has to complete entirely before you even start the network request for the subcomponent. So you're sort of baking in, or you're architecting in, a bunch of network waterfalls.
Okay. There's a lot of features here,
Yeah,
right? So,
yeah.
and I'd like to kind of dig into each one, but we're not going to dig in too
Yeah.
deeply. We were talking before the show, before we started recording, and I think, the idea that you can bubble up all your dependencies from the children all the way up to the top, and then when you do your network query, that would all get passed down, and you make sure you're getting exactly what you need. And like you said, it generates that query, right? So that's also interesting to me because I'm kind of curious about, maybe I missed that part, which is how does it know what's available from the query?
So with GraphQL, you also specify what fields are available in a schema declaration. So there's one file that says on the blog, there is an author and content and whatever. These fields exist. And the compiler, when it scans your Isograph literals, it will make sure that the fields that you're selecting actually exist. And otherwise it'll emit errors if you're selecting something that doesn't exist.
Well, just a caveat to that one too, right? I just wanted to say, which is quite interesting too, is that you did have a way to make, I forget what you called it, like compound fields or something, where you gave the typical example of first name, last name, then you can make a full name, which doesn't actually exist, but it's, you just combine it, right?
Yeah.
What's that called again?
So the term we're using in Isograph is called client fields for this.
Okay.
And so this is a field that looks just like a server field from your perspective. You're writing the blog post component and you want to select the author's, well, you're on an author, you're on a user. You want to select their full name, but the server only knows about first name and last name. So if you define a field called full name, the compiler, when it encounters full name and it generates the query, it will actually generate a query containing first name and last name. And then before the component that uses that full name field is called, before that function is executed, it will first execute the full name function, which just concatenates those two and gives you the result of that function call. So that makes a lot of sense for first name and last name. That's pretty standard stuff, right? But what's cool about Isograph is that the client fields can return anything, including other React components. So the way Isograph has you think about building apps is as a tree of client fields. So you might imagine a home page, which has a header, body, and a footer. And the header might select the avatar URL and whatever links you have available, select some fields. The way you would write that is by selecting the header, body, and footer. And then in the header component, you would select the avatar component, and the avatar component, you would finally select a field that exists in the schema, the avatar URL. And then all of that gets compiled into a single query, which doesn't contain the header or the avatar component or anything like that, but just contains the avatar URL. And if you select a client field in another client field, these are, sort of composable in that sense, that client field, which is a set of data associated with a function, that function gets executed, and the result is passed to the client field before the client field executes. So you can sort of imagine that you write this tree of client fields where it's client fields all the way down before bottoming out at server fields, and then it's all of the components that only use server fields are executed, and then you sort of go all the way up, 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 back to the root, and then finally the home page component is executed, and it gets a header, which is the result of calling all these functions, and the body and the footer, and then it does whatever it needs to do that. In particular, it just paints it to the DOM or something.
Before we go off too much, I almost forgot that both of us at least know a bit about
Yeah.
GraphQL. Maybe we can kind of talk a little bit about what is GraphQL and talk about the different types of I don't know what you call those, because you have queries, mutations, and also subscriptions.
Yes.
Because I'm also kind of curious about if all of those work well with Isograph, but maybe we first talk about the basics of GraphQL and then we can talk about that part.
Yeah, sure. So GraphQL is a language for making network requests to a server. So in particular, it has one killer feature, which is sort of fragment composability. So you might imagine that the header has a header fragment, and in that fragment, we include another fragment, which is the avatar component fragment.
Maybe we talk about what a fragment is, because I'm not
Oh,
entirely
okay.
sure.
Yeah, you're right,
too.
you're right, you're right. Yeah, keep me honest here. A fragment is just a collection of fields. So a field is something that the server knows how to provide. So a user's name or user's age or whatever are fields. And GraphQL defines this tree of fields. So you might start at the root, which is usually the query object, and that might have a user with a given ID. And then on that user, you might be able to select the name or their best friend, which is another user, and so on and so forth. And so you build up this entire giant sort of tree. And then in order to execute, when you actually make a network request, you pick a finite set of fields from this possibly endless tree that the server defines. And then that server gives you back that tree in sort of a JSON format containing exactly the fields that you asked for and no more or no less. So the killer feature there's two killer features, I guess, of GraphQL. One is that you can select exactly the fields that a given screen needs. So in particular, it means that in a properly structured GraphQL app, the data that you get for a homepage is exactly the data that that homepage needs. And the second killer feature is fragment composability. So in a properly structured GraphQL app, each sort of component or file or function will define a fragment that includes the data that it specifically uses. So the avatar component fragment might select the avatar URL field. And then because that fragment is contained in another fragment and eventually is contained in the sort of the homepage query, the server knows that I need to return the avatar URL in the network response. And this gives us one really key feature, which is that you can reason locally. Every single file declares its data dependencies locally. And for example, with Relay, there is a lint rule that says if you're not using a particular field in a particular file and you select it in a fragment, it's going to complain. So you have no unused fields. And also, because of how GraphQL works, you also have no missing fields. So that's the gist of it. But the point is, it's a way to make network requests to the backend that returns exactly the data that you requested, and the data can be co-located with different components.
Yeah, well, to me, the benefit of this too is that it's typed, so that you know exactly what's coming back, and you also know exactly what's nullable, which is also interesting too. And not to mention, as a developer, the thing I like the most is, at least one that I'm working with, is that if somebody sends me malformed data, it'll just get rejected. And actually, I have no idea that anything even happened because it gets rejected at like an outside layer. I'm not sure if other languages do the same thing or not, but to me, that's the benefit. And also, I can write my own types. Like for instance, we had an issue where we're using ID, and ID is just a string, right? Which makes sense because you don't know if it's going to be like a number, like an integer, or it's going to be like a UUID. In our case, we had somebody sending an empty string for an ID, and we were having errors because we were expecting UUID. So I went ahead and said, okay, no more IDs. Now we're using UID. And then I can actually say, does this actually parse the value UID? And I can reject it and then have nothing to worry about. No more errors in my backend code. It's just kind of stuck at that layer. And I think that's probably one of the benefits about that part. And also it's self-documenting too, right? You just point your client to there and then you get all the information. If you document it, it's like, okay, this is this, that's that. This is what this is. I mean, you can have so much interesting stuff. So we talked about queries, right? Mutations, I think, is also interesting to talk about too, because technically, I mean, there's not much difference between them other than actually, well, there's a difference, but actually you can mess it up still, right?
Yeah. In GraphQL, queries and mutations, I think of them as essentially the same thing. They're just
Yeah.
rooted at different top-level objects. But semantically, a mutation is supposed to be executed once and it has side effects, but like none of that's really enforced by the GraphQL spec. So you can think of them as fundamentally the same thing. But there's actually a problem, which is that you think of queries as persistent, or as like the data is cached, right? So you might select a current user and their name. And then if you want to modify the user's name, you make a mutation.
Yeah.
But that mutation, it's rooted off of a different object, right? Instead of going from query to user to name, you go from mutation to set username to name. And in a cache, you sort of need to know that the user that you modified is the same one. So you, for example, will need to select the ID in both cases and then use that ID as the key in the store. So let's say we're back at that example, and instead of setting the user's name, we set the user's best friend. So we have in our query, we have the query, user, best friend, name. And then in our mutation, we set the best friend to a different best friend. Now when we re-render, we go back and we select the query, user, best friend. We still have the best friend, but we select their name, but it's a new guy, or a new best friend. And we didn't get the new best friend's name. So now our app has to deal with rendering missing data. So that's a problem. And the problem with that is not specifically, oh, I need to select the best friend's name. Like, okay, that's solvable in one case. The problem is you have no idea which fragments are rendered off of a given user. And you have no idea what fields you need to select in the update best friend mutation. And generally, the solution in GraphQL is to overfetch. Just like, missing data is a problem. So just like spread a bunch of fragments in the mutation. So if you have some component like the best friend display, include that fragment in the mutation response. So just in case somebody is using the new best friend's name, you have it. Isograph takes a different approach here, which is that instead of mutations being sort of this other completely separate object that coincidentally modifies the same object, instead, Isograph gives you a way of saying, if I'm on a user and I want to update their best friend, now there's a client field. So remember, a client field is just, it looks like a field, and what you get out is some arbitrary value. A client field on the user called setUserBestFriend. And Isograph is smart enough to know that the function that's returned here, if you call it, it makes the network call to execute the mutation. The fields that it selects in its network response will be whatever is selected off of that user. So you might select the query, user, best friend, name, and then also select, update best friend on the user, and when you call it, it will automatically include the name. But then somebody else comes to your app and adds a best friend age component, and you don't even know about it. But just transparently, that set best friend client field, when executed, that network request for the mutation will now start to include the age field. And this is all done at compile time. There's no dynamicness to this. There's just, at compile time, we see all the fields that are selected on that user at that location in the query and select the correct ones. So that's, still needs some work, but I think it's a really, really nice default, which is that essentially we're saying is that this field or this item is invalidated, and just select all the fields that are selected on that object. So I think that's a little bit of a better mental model for how mutations should work. And the reason we're able to do this is because the compiler has this sort of global knowledge of all the fields that are selected on the user at a given location in the query. And the compiler is the only thing that should have global knowledge. You shouldn't have to. And right now in GraphQL, you need to have global knowledge in order to make mutations and subscriptions and so on work correctly without dealing with missing data. So that's how mutations work. Subscriptions will work really similarly in the sense that if you have a subscription that returns a user, like on user change or something like that, you really should be able to start that subscription rooted at a given user.
Okay. The interesting part about subscriptions GraphQL is there's like no standard in terms of like how they're, I don't know what you call it, how they're implemented or something. Because I use a lot of Elixir, and then there's this one called Absinthe, and it runs off of Phoenix Channels, which is like an abstraction on top of WebSocket. But like you have to have a specific client for that, and it's kind of like I stopped using subscriptions because of it being so specific. There's no standard because like everybody implements Apollo, right? It's kind of like the standard when it comes to GraphQL, as far as I understand, at least at that time. And I was using the specific one, and I found that it's like, wow, this is kind of really annoying. I'm just going to go to something else because if I use the channels directly, I can actually have bidirection. I could send data and receive data over WebSocket, which is more interesting than just receiving a subscription, in my opinion.
Mhm.
Right. So, like, I find it interesting how you can actually use Isograph with subscriptions because of that limitation.
Oh, just to be abundantly clear, subscriptions are not currently supported in Isograph. It's on the long roadmap. So,
Okay. So I'm guessing you have to make the transport part like open.
I mean, Isograph right now it's front end only. So like whatever your server does, Isograph will, if it exposes a subscription, Isograph doesn't care how it implements it or anything like that.
Okay.
So it's up to the server, like the implementation is up to the server. And Isograph doesn't really care about that.
Okay, because most of the client libraries I worked with is like they're like, okay, give us the URL, and if you have some header data you have to send to it too, like for authentication, give us that, and like that's as far as configuration I remember seeing, but it's been many years since then. Well, we've also been talking a lot about GraphQL and front end stuff, but this podcast is all about Rust, and now the question is, what does that have to do with Rust, right?
Yeah, yeah, absolutely. Icegraph is powered by a Rust compiler, and I think that this compiler, it's not the world's most complicated compiler. It is um, basically, it does like 5 things. It processes your GraphQL schema, it processes all of the Isograph literals and Isograph entry point literals, and it generates a bunch of files. So I guess 3 things in this new summary. Oh, sorry, it validates each of those. That's why there's 5. And the validation is things like this field exists, or like you're selecting this field in this way, and that has to be correct. It has to match how the field is supposed to be selected. And it's cool. Like both of the parsers for both the schema and for the Isograph literals, they're LL1 parsers. They're pretty easy to reason about. I haven't done any benchmarking, but it's probably decently fast. And also the test projects are fairly small, so there's no performance issues yet, which is kind of nice. And in terms of the validation, like the extremely high level, when you first create the internal representation of all the possible fields and stuff like that, we call it the Isograph schema. And when we first create the schema, that data structure is generic over the pointer type. So in particular, at first the pointers are unvalidated strings. So the reason that's important is because if you look at a GraphQL schema, it might refer to a type that shows up later, that is first defined later in the schema. So we need to take one pass to create an unvalidated version of the schema, and then another pass to validate it. And the same thing is true for the Isograph literals. One client field can refer to another, which has not yet been defined. So at first, in-memory representation has sort of strings, essentially, for the pointer types. And then the process of validation, all it is looking up those strings and replacing them with an index or a pointer. And then we have a validated one, and then from then on, if anything is wrong, we just panic, but we assume that we will never panic. And file generation part, that's just like a morass. It's kind of, it needs some cleanup, and it needs to be made, I guess, more separated so that we can start generating, Objective-C and so on and so forth, or Swift, I guess, and Kotlin and so on and so forth. But yeah, that's the gist of the compiler.
It's interesting to hear. Like, so wait, first question I want to ask is it a compiler or a transpiler? Because it sounds like it may be more of a transpiler, no?
I mean, you don't write GraphQL with Isograph. So
Okay.
I think if the definition of a transpiler is from the same language to another flavor of the same language, then like it's probably not a transpiler. It's probably more of a compiler. But like I'll admit that it's not the world's most complicated compiler. And Isograph literals, they look like GraphQL. They're not GraphQL, but they look like GraphQL, so it kind of looks like a transpiler. So pretty close.
Okay. And I'd kind of like to talk about why Rust, right? Because I think if you go back, I think at least in the beginning, most of the tools for JavaScript were written in JavaScript and possibly some TypeScript. I think within the last couple of years, there's been a big push to say, okay, we all know JavaScript is not the fastest, even with Node, right? So there's been attempts at looking at Go and of course Rust. Why choose Rust over, say, Go or even C or whatever else?
Yeah. So the reason I chose Rust is because it's my project and I do whatever I damn well please. And I like Rust.
It's probably the best answer so
Yes.
far.
It's the honest answer. But a lot of what I'm building was previously done in Relay, especially with respect to the compiler. And the reason Rust was chosen for the Relay compiler was not that it's an awesome language or that we really like the borrow checker, like none of that. The Relay team considered a bunch of languages from Java to C++ to OCaml and a few others.
Should be some Kotlin in there too, no? And I
Uh,
think
Maybe. I don't remember Kotlin ever being mentioned, but
okay.
presumably. For the same reasons that Java was disqualified, Kotlin probably would be disqualified. And the compiler, for context, was previously written in JavaScript, and incremental improvements in compiler performance were just not keeping up with the growth in the number of fragments and queries in the Facebook codebase. So they had to do something sort of drastically different. And the problem with JavaScript is that there's no way to share very large data structures across threads. So the GraphQL schema that could take maybe even gigabytes of memory of RAM per process. So one, just processing and loading that into memory was going to take time. Two, if you have 64 threads doing this, like now you just ran out of RAM. And so ultimately, like even trying to do multi-threaded JavaScript in the sense of like having multiple threads that sort of communicate using some sort of serialized messages was never going to work because each thread would have to have too much stuff in memory. So the team looked at a bunch of different languages and they wanted multi-threaded support. They wanted a lack of footguns. So C++ was ruled out.
So what's a foot gun? And
Oh, a foot gun. I mean, it
shoot
means
yourself in the foot.
yeah, shoot yourself in the
Okay.
foot. Ways to accidentally, blow up the world. And they wanted sort of predictable. Well, okay, and I think it was the multi-threaded, like the Rust's like safety with respect to multi-threading that ruled out Java and so on. And so ultimately, it's not like the cool features of Rust. It's just like the fact that Rust has all like the basics really well worked out. Like you can easily share stuff across threads. Send and sync make it really easy to write code that is safe in a multi-thread context, or the compiler stops you from using something in a multi-threaded context, and so on and so forth. And so that's why they ended up using Rust. And out of the box, the unoptimized Rust compiler was something like 85%, if I recall correctly, faster than the JavaScript compiler. And it wasn't doing anything fancy, it was just multi-threading and sharing large data structures across the threads.
But how do you actually figure out what you can and cannot multi-thread? Because sometimes you can multi-thread something that may make things actually slower because you have to wait for, these threads to communicate, right? Do you like make like a tree and then figure out like which things are dependent upon which, and then like you can start from these two ends?
Yeah, there's fairly coarse multi-threading in the Relay compiler. So
Okay.
you might imagine that every single fragment needs some sort of validation, and or every single generated file needs to be, figured out, and what the text is needs to be figured out. And so we basically have a trait that in a single threaded context is just a loop, and in a multi-threaded context is par iter, that will iterate over all the fragments and do sort of the validation sort of independently. But it's nothing super granular. It's like, if I recall correctly, it was on that level. And I don't know whether we did any benchmarking to see if like larger chunks would be better than smaller chunks or anything like that.
I know that there's ways that you could say, okay, we're going to suck in so much data because the way the memory's laid out, and it's beyond my scope.
Actually, one thing that's interesting is that in the Relay compiler, everything is behind a atomic reference counter pointer, arc. Atomically referenced counted? I don't know what arc actually stands for.
Automatic reference count or something like that.
Maybe, yeah. So anyway, it's something that you can use across threads. But because they were, for let's say the validation pass, there's no mutation of the underlying object. So arc is really, really fast at giving you read-only access to the same data structure.
Yeah.
So I would have thought that, passing references around instead of using arcs would have been more performant. But like realistically, when we did the benchmarking, all of the time was spent in a single transform, not looking up the data behind the arc, but because certain transforms needed to have global knowledge, like do sort of more intense validations. And so even if we didn't use arcs and just use like references, Like that would have, I don't know, made it 0.1% more performant. I don't know exactly how much, but like it would have made it more performant an insignificant amount.
Yeah.
So it's kind of cool. Like you should really just benchmark. And sometimes the easy approach is good enough.
Yeah, I think I heard quite a few people say like, the unoptimized first pass already gets you like most of the way there, and then like, yeah, maybe you can ink out max 30% more, but usually it's like, all right, this is already Rust. This is just already pretty much where the hell we're going to be at, considering everything else.
Hmm.
But I find what I actually usually see. Usually, people see people post snippets on Reddit and say, what do you guys think? And then you have interesting input from people like, oh, if you use this, if you use that, dude. Because people say, oh, I wrote this in C. Here's my C implementation. I wrote this in Rust. Why is Rust X amount slower? And then they'll say, well, you should try this. You should try that. They have different ways to speed up. Like you said, Arc give you some improvements.
Yeah, it's hard. It's hard to look at a tiny snippet of code and have any actual sense of how much an improvement removing a clone will make a difference.
Yeah. I would even imagine that sometimes even cloning may even be faster. I don't know. Who knows? Like, I think it also probably depends on CPU and everything else too, right? There's all kinds of weird stuff.
Yeah. I know I have like fairly low hanging fruit in the Isograph compiler, so I'm not super concerned about low level things like cloning. I try just because, I enjoy writing Rust because it's like solving a puzzle, right?
Yeah.
Sometimes that there's a good solution and then the compiler is telling you like you're wrong here, but it's not telling you what the actual solution is. And the satisfaction of getting it all to work is really nice. And that I think is my motivation for removing a bunch of clones and being very clear about like what's a reference, what's a mutable reference and stuff like that. But I know that I have lower hanging fruit. Like I need to implement a topological sort in the compiler because we do a bunch of work redundantly when processing client fields. And if we just started from the client fields that are sort of at the leaves and then worked our way up, we would be able to do substantially less work. But instead we sort of process them in an arbitrary order. So I guess I'm just not concerned so much about clones at this point.
You did mention Relay a lot, right? Is this already compatible with Relay? Because Relay is probably, for me, I know that's whenever I do pagination with GraphQL, I definitely look at Relay. So this works fine with Relay out of the box, right?
I mean, it plays in the same space as Relay does.
Okay.
And I think theoretically I could have some sort of like maybe could have an automated way to convert a Relay component to an Isograph component or an Isograph client field, but it's not compatible in like a literal sense. But it takes all the good ideas that Relay has, which are plenty, and tries to incorporate them. And then I think it tries to improve upon it in sort of a developer experience kind of way in some other ways.
So for this compiler, right? I mean, for Isograph, how do I actually get it started, right? I'm guessing I don't need to have Rust, right? I'm guessing you have precompiled binaries out of the box, right?
Yep.
Is this where if I need to npm install something and then there's a compiled version there, or do I have to like use, I don't know, Homebrew or download it from GitHub, or how does it work for the installation part?
Yeah, you can install it with npm, and then installing, I think it's at isograph/compiler, will add a npm run iso command to your project, and then you need to define a isograph.config.json file at the root of your project. And that just says like, hey, I want the artifacts to be generated in this folder. I want you to look in this folder. And then, here's some other options if you need them. And then you can just run npm run iso. And then there's also a Babel plugin that if you're using, let's say, a Next.js app, you need to manually install that as well. And yeah, and then it just works. So that's actually one thing that's pretty cool is that I'm really happy that the installation process is that simple. And the way it works is that in CI, we generate a binary, we upload it somewhere, and then the Isograph compiler package, which is like a JavaScript package, checks what system you're running on. So are you on Windows, are you on Linux, are you on Mac? And it downloads the appropriate binary and executes that.
Yeah, I was curious about, because you have Rust, right? So I'm thinking in my mind like, okay, does it really run an actual binary file, or because now we have like WASM, right? Because I can imagine, well, it's written in Rust, so why can't I just export a WASM version that could run in browser, that could just run on Node? Because I think Node can run WASM directly, right?
Mm-hmm.
So then you could theoretically just, like for an OS that can run Node, but maybe you don't have a build for, let's say, Solaris or something random out there, you could have something like that, some kind of fallback option, because of Rust.
Yes, yes. And I definitely want to do that. Like the things that are in the way of me generating a WASM binary right now are that there is file IO being done. And well, the main reason I want WASM is because I want you to be able to go to isograph.dev and play around in a code sandbox where Isograph is running and you can make changes and it modifies, generates files, even though there's no actual file system. Or I want you to be able to go to isograph.dev and write out some isograph literals and, let's say, see what kind of data structure the compiler generates. So right now there's no files. The file system access is not abstracted out. So one thing I need to do is, instead of calling the file system APIs directly, I need to like have some sort of trait. And in a WASM world, that trait is, I don't know, maybe it just panics or something, but it does something else. And then in a regular binary world, it actually makes the file system calls. But yeah, I definitely want to compile the Isograph compiler to WASM and expose it in the browser. But that's actually a really interesting point, that I could use it as a fallback for Solaris and, Raspberry Pi or
Yeah,
whatever.
who
Yeah.
knows? Because that's the thing that always, like, I knew that people were using Rust to write things like some kind of utility things like this, but I was always curious about how that worked, and it always popped in my mind, like, I'm guessing they're probably using WASM, right? Because for me, it didn't pop into my mind that you would actually be able to download a binary file and actually run that directly. But okay, yeah, it makes sense. A lot of languages actually do that.
Yeah, I mean, this is honestly one of the things that I think could be improved about the ecosystem, is that a lot of what I'm doing right now has nothing to do with Isograph, and all of these things should be separate packages. So the ability to upload and download a binary that's built for different systems, and the integration with GitHub CI and stuff like that all should be just a package, and it should be really, really easy to use and install. But instead, I had to like figure out, how does Relay do that, and then kind of emulate that. And the Isograph compiler, it watches all the files in a given folder, and then it generates a bunch of files. Like, I mean, that really also should be like some sort of library. And like, if you want to use that same library to write some sort of OCaml thing, then it should work just as easily. And that's also something that I'm sort of like implementing on like a too low level. And likewise, a lot of the stuff for language servers, which is like how you get autocomplete and like, go to definition and stuff in VS Code, or usually you do. That stuff is also something that I'm sort of implementing separately, but it should also just be like a set of utilities that are like separately packaged. And so one of the things I want to do with this project is like try to be aware of what I want to carve out in advance and do that, because I want other people to be able to build their own tools based on like the stuff that I've built for Isograph, or if not built, then just copied from other projects.
With this though, if I remember correctly from your presentation, I'll try to remember to link that into the notes. You actually have your own, like, I don't know what you call that, language or something that you
Mm-hmm.
would be able to attach all these things with. I'm kind of curious, like in Rust, I mean, how difficult is that to implement reading of a specific type of language that you're just kind of inventing? I mean, that sounds pretty low level. What I have done somewhat recently was actually use Rust to read in a schema GraphQL file and actually write TypeScript. I'm guessing SWC, you probably heard that before, right? I don't know if it's called Swick or what is that word called, but because I saw those two things, I'm like, okay, I'm writing this translator or whatever. I called it a translator. I don't know what else to call it. And it made life easy because the project I was working on was we had, TypeScript and we had, GraphQL, and the GraphQL was always changing. But we wanted to be able to have TypeScript classes, or actually they were TypeScript. Maybe you can help me understand this one. They're called TypeScript interfaces. We just switched to interfaces for some weird reason.
Yeah.
I get confused between interfaces, types, and classes with TypeScript. It's a little bit confusing to me.
Same.
Yeah, everybody questions this one, and nobody's able to understand it
Yeah.
entirely. Anyway, so I ended up using interfaces, and it worked out great, except for like because we're using Relay, we had these like node things in between, and it made stuff so complicated. But anyways, like I knew that Rust could do that, right? But then inventing some kind of way to like read and tokenize everything, how was that process?
So I've written compilers before, like very basic ones, or I guess I've written parsers and, like before. And I don't think the hard part is writing a parser, and I'm just using some library to tokenize. Um, I don't remember what the name of it is right now. And the hard part is not writing the compiler. The hard part is not reading a file and then using a regex to extract the isograph literal and passing that to the parser. And the hard part is not, once you have this data structure, like sort of knowing what to do with it. I think each individual step is easy. I think what was difficult is like knowing what to do in advance. Like, why didn't I just use GraphQL? Well, it's because I think that the GraphQL language has a lot of flaws with respect to the front end. So they're really niche and whatever. So I'm not going to go into them. But like, there's things that I can do by writing my own language that I wouldn't be able to do if I was sticking with GraphQL. But the language looks pretty similar to GraphQL. I mean, in the end, like if you're selecting the user name, like it's user open curly name, close curly, right? That's pretty familiar. That also gets back to like my previous point that I feel like most of these things should just be like plug and play because like each individual step is not that hard. You should be able to just install a library that says like, hey, I need a parser. Hey, I need to know what files to look for, or hey, I need this, this, this. And then like each individual thing is just like, it's just a function. We can write functions. It's understanding how they all fit together that like is more difficult. And I think the only reason I knew that I had a good vision for how I wanted the language to differ from GraphQL is because I had been working on the Relay team for about 3 years and, had come face to face with like some of the limitations of GraphQL and had generated some strong opinions on how I would like it to be instead.
Yeah.
Yeah. But I do think that in the long term, like writing my own language, it comes at a cost. Obviously, it means I have to write my own, not just parser and stuff like that, but also like VS Code extension to provide syntax highlighting and go to definition and so on and so forth. But I think that the benefits in the long term will outweigh the negatives because we can do a lot of really cool creative stuff that would take years to do in GraphQL in just a fairly short amount of time. So like one thing, for example, is, and I haven't figured out exactly how this will work, is you might imagine that you're selecting a user's name. That name field might not have been selected. We might have gotten a different user, like this user is the best friend, right? We might have gotten a different best friend and name has not been fetched. So on the other hand, it might be fetched, but the field might have errored out when we were executing name on the server. Or it might not have errored out and it was fetched, but it might be legitimately null. So there's 3 things that we have to unwrap in order to get to the actual username. And I would imagine that if you unwrap the has this field been fetched or not, and it hasn't been fetched, then effectively the user shows up to your component as like, oh, the user has not been fetched. And if you unwrap it and it has errored out, then that error sort of propagates up to the user and so on and so forth until you have some sort of boundary that catches these. So that's the kind of thing that I want to add syntax for. I want to give you precise control over when and where you show data to the user. One thing talked about a lot is the best friend's name problem, like the missing data problem in light of mutations. And it's not just in light of mutations. You might make another query, and in the meantime, the user's best friend has changed on the back end, and so now the best friend's name is missing for some component. So basically, any query could potentially change the state of the world. And that's fine and dandy for an app like, a social media app, because if we don't know who wrote a given post, written by question mark, that's okay. Like, or we just don't show that field, that's okay. But on the other hand, if you're trying to use GraphQL for something like a banking app, and we don't know how much money is in your account, or the latest price of, whatever security that you own, like that's more of a problem. And so I think the fact that I'll be able to add syntax level support to precisely control what kind of data we show to the user is in the end going to make GraphQL, or, if GraphQL is just an implementation detail, make Isograph a good choice where GraphQL is not, for certain apps where GraphQL is not. That's sort of the motivation for writing my own language. And I guess that there's like just a few other things that are like, I think, like fragments aren't their own fields in GraphQL. They're sort of like part of the parent object, and that's just confusing. And the big difference between client fields and fragment spreads is not only that they're pre-associated with some sort of function that's executed, but also that they are their own field. So that means that like if you have a client field that's only executed in certain conditions, for example, if a given type matches a given interface, then that client field could be missing on the parent object if it didn't match. And like that's just not something that's expressible in GraphQL, because the fragment spread is just part of the parent object. That parent object exists, but like you don't have any indication to know that, oh, I'm not allowed to read this fragment spread because the types don't match. So these are just like some of the things that I think are limitations of GraphQL, and it's to no fault of the GraphQL project that it's like this. GraphQL is many years old and there's committees, like it changes slow and stuff like that. But I do think that it's exactly the kind of situation where Isograph can move faster, and hopefully a lot of these changes, if they work out, end up getting upstream to GraphQL over time.
That's typical, right? Because you're kind of like a small wave hitting a Titanic and trying to, force it to move in another way. It's not impossible, but it's going to take some effort and some really clever and then ideas, and also probably a lot of outside people saying, yes, we really want this to be part of the standard, right?
Yeah, 100%. And that's why I want people to collaborate on Isograph. There's a lot of issues that I just recently actually like fleshed out and put on the GitHub, including good first issues and like whatever amount of like support people need to help out on the project. I'm like here to give it.
Yeah.
Yeah, 100%. This is a multi-person effort. Like I've been putting a lot of work in the last year into this, and I think that within, let's say, 6 months to 12 months, something like that, it'll be a very legitimate choice for people building apps, and then over time it'll become the best choice for building apps that are data driven, which what kind of apps aren't? I don't know. It won't be the best choice for building marketing pages. I think that that niche is heavily, heavily, heavily handled by all of the sort of the mainstream frameworks. But for data driven apps where consistency is important and performance is important and stuff like that, I think Isograph will be the best choice, let's say, a year and a half from now. But yeah, it's going to be a lot of work.
I just want to ask, like, in the immediate future, like, what features are you planning to come out with?
So right now, I am mostly personally focused on getting feature parity with some of the important relay features. So for example, right now, if data changes in the front end cache, then every single component re-renders. And that's just because I didn't need that for the demo. And I want to add granular re-rendering. So if a certain field changes, only the client fields that actually read that field will re-render. And that's really important because, like, for example, if you paginate, scroll down like a news feed, like 3 or 4 pages, now you have like hundreds of components on the screen, especially if you're not doing some sort of like virtualized list kind of thing. And if you re-render every single one, whenever anything changes, then like the third pagination is going to be a little bit slower, fourth one noticeably slower, fifth one, and so on and so forth until someone's like, whatever, I'm just resetting or refreshing. So that's an important feature that I'm working on. I recently shipped a very early version of garbage collection. So if you go from one page to another and some of the records in the store are no longer referenced, they will be removed from the store so that the store does not grow without bound as you start to use the app. Edmondo is working on going from abstract types to concrete types. So you might have an interface like a node and you want to say like, hey, if this is the equivalent of dot 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 on user, do this. Right now we're adding special client fields that do that in Isograph. Other big projects include the VS Code extension. I want to be able to generate client schema extension files. So GraphQL is a concept of client schema extensions, which are just like addenda to an existing schema that you can then plug into GraphQL. So then in GraphQL, you can see not only your server fields, but you can say like, hey, on the user, you also have a user avatar or a username display or a user email component. And those will show up just as if they were other fields in GraphQL, which I think is honestly like that's one of the killer features that Isograph is going to have, is the ability to say like, if you're on a user, I want to be able to surface to you that, hey, there's already a user avatar component. You don't need to write your own. Because like in any large app, there's like 4 or 5 user avatars always. And that's silly. There should only be one. So I think it would just be really nice to be able to have a VS Code extension and also GraphQL suggest to you like, hey, here are the components that are already on this object. Because you often know what data structure you're on. You might be on a given user, you might be on a given blog, you might be on a given whatever, but then the discoverability of the actual components is way worse. And so that discoverability will be another feature that we need to build out. And then there's creating the generated files in Swift and in Kotlin, and that shouldn't be that difficult. Like the runtime is fairly small. I mean, not that difficult, conceptually. Still probably a lot of work. The runtime is fairly small, and the generated files, they're basically glorified JSON with like one import of some exported function from another file and some generated types. All of that should work in whatever language we want to generate. Maybe even like for terminal UI stuff, that would be pretty nifty. That's some of the stuff. I think the most urgent stuff is the runtime parity work, and also more ways to execute mutations and subscriptions, because what we previously discussed might not work for all mutations. And with that, it'll be a good choice for apps, and I'll just like build out some demo apps that maybe hopefully people will find impressive and, get some users from there.
If you were to start for another language, like, do you know which language that you would prefer to start with in terms of kind of bringing this to another language? Wouldn't be Rust?
It would be either Swift or Kotlin, because those are the biggest markets. And there is no good solution that is sort of cross-platform in that sense. Like Relay is if you use React Native, but it's, you can't use Relay with Android stuff directly, with Jetpack Compose directly, and with whatever iOS solution there is, Swift UI. And likewise, Apollo has 3 different libraries, but they behave like kind of substantially different from what I hear between JavaScript, iOS, and Android. I think that Isograph has the opportunity to be, a very good cross-platform library in that sense. And actually, this also reminds me of another thing. The full name client field that we discussed earlier, first and last name, I want you to be able to define that in Isograph. And then based on how that field is selected, that function either gets executed on the front end, which is sort of the default way, or Isograph should be capable of teaching your GraphQL server about this full name field. And then we just are able to select full name and then, get the result down, passed to the front end. So there's at least sort of like 8 different options here, which is like 2 cubed. One is like, is this executed on the server or executed on the client? Do we know about the dependencies on the client? And so when those dependencies change, do we know to re-render or not? And when we re-render, do we re-execute it on the client, or do we sort of make another request to the server? Oh, sorry, combine those last 2. The third of those 2 to cubed things is, do we make a subscription on the back end to the first name and last name field? So you might imagine a world in which you select the full name and then also start a subscription to the first and last name fields. And then whenever those change, sort of the backend just informs.
Recalculate, right?
Yeah, we need to either it sends down the full name again, or it says, hey, this has been invalidated, so like make a network request or whatever. And not all of those 8 possibilities make sense. One of those is do nothing. But like, if we, so that one's probably not good. But that's sort of the idea, is that we want to be able to teach the server about stuff that you define on the front end. And so maybe in the long term, like you would define everything on the front end, or in the same project rather. And then all that Isograph is an entry point to the homepage. Homepage is like header, body, footer, and concatenate them. And then based on that, like it's all just sort of one project. And like, if you wanted that homepage pre-calculated on the server, like, yeah, you can do that, or you would be able to do that in this world. And does that sound like React Server components? Kind of does. And if we just pre-calculate on the server, but then make everything still sort of updatable on the front end, now it's just server-side rendered components that then get hydrated on the front end. And so I think that's actually one thing that's quite nice about the Isograph mental model, is that it unifies a lot of different concepts that people don't realize are the same thing, but are really take some data, pass it to a function, and give me the results of that function.
I was just thinking in my head, if we're using Rust, we should be able to kind of use some of that in the native code, right? I'm not too sure if it would actually be useful, because I think recently, didn't Swift have more integration with like FFI like directly, so that you can start calling, say, Rust code directly?
Oh, that would be really interesting. Yeah.
I don't know if it's possible or not, but it'd be interesting to take a look at, because even Android too, I'm sure, has got some more interest. I mean, mostly Kotlin, right? Because Google doesn't want to go near Java since the whole thing, I think.
Yeah.
But I would think that it's possible that you could probably end up reusing some of the stuff. Maybe you could, I don't know, call into. I have no idea. I leave it up to you how that could happen. But I'm just curious, because you're using Rust, you should be able to possibly reuse some of that stuff in those platforms.
Yeah, I wonder, like, what that brings to mind is like maybe you write your client fields in Rust as essentially functions of some data to some arbitrary value, and then like that gets compiled to WebAssembly or something like that. And then now you can include those client fields in a Kotlin app or in a Swift app or whatever. I mean, I assume they can use WebAssembly. I actually don't know these things.
Yeah, I don't
But
know either.
if they can, that would be quite interesting.
I have to see what's going on. I'm guessing that because with all the talk about WebAssembly on servers for the past couple of years, I don't see why we would not be using that stuff on mobile, but I'm not too sure what's the current status of WebAssembly on those kind of platforms. Usually everybody's using WebAssembly in the browser, right? I did hear about like Photoshop and Adobe. They want to get off of the client stuff and have everything in the browser, so that way they can always charge everybody and not worry about pirated copies, right? That's what I hear, but I don't know what the
Yeah.
truth is.
Yeah. With WebAssembly, I mean, last I checked, bundle sizes were still a problem.
Yeah.
And in particular, if you're going in and out of WebAssembly, which what I just described sounds like one would be, you get a lot of overhead from, serializing and deserializing objects.
Yeah.
This might be a really poorly performant thing. But on the other hand, if you're just trying to get something off the ground, like sometimes you can over optimize. But just being able to ship a iOS app and an Android app and a web app like quickly, that's more important. Like React Native has performance problems, but like still a lot of people use it and they're happy with it because they're not building, the next YouTube or TikTok or whatever that like where performance really, really matters.
Not to mention kick it off to the CI server to handle, and they don't need to wait on it. It's
Yeah.
probably something people would end up doing if that was the bottleneck, right?
Yeah. This sort of gets at, I think, the really big long-term vision for Isograph, which is that every single page or whatever is sort of an entry point, which is to say it's a generated query. And it is a generated query with a bunch of functions that sort of hang off of some parts of that data. And one limitation of GraphQL currently is that it's really difficult to specify all of the states that your app can be in the query. So for example, you might have like a set of 3 tabs. And if tab 1 is open, you care about the blog name. If tab 2 is open, you care about the blog author. Tab 3, whatever. The only way to implement that in GraphQL is with 3 Boolean variables and an @include if for the data in each of the 3 tabs, right? But maybe with compiler support, you can imagine a world in which all of the data, all of the state that controls which data is visible on a given page is embedded in the query. And it doesn't feel like 3 Booleans. It feels like a single discriminated union or an enum. And then whenever that state changes, you can either make a new query for exactly the data that the component in that state needs, or you can do something smarter. And that gets me thinking, it's like, what is the state that we're concerned about in this case? It's not just like which tab is open. It also is like, am I on mobile? Am I on desktop? And you can imagine a world in which if you're on mobile, the user avatar component that your header is provided will render a small image. And if you're on desktop, it'll render a big image. Or if you're on a fast Wi-Fi, you'll get a big image. And from the header's perspective, remember the header selects an avatar component client field. From its perspective, it doesn't care what actual concrete value it gets as long as it conforms to the contract, which is to say the type matches, I accept these props and I return JSX or whatever. So like there's some sort of like dependency injection thing where that needs to be sort of fully fleshed out. And you can imagine like maybe you're testing the header component. Well, what avatar should we get? I mean, it's probably just like a div with a test ID, right, at that point in time. And so what controls what we receive? Well, it's some sort of context, right? And really the answer to me is like, essentially what I'm describing is a very full-featured bundler, which is to say, Isograph in the long term is going to be a bundler where every single page is going to be some sort of bundling of like, here's your state, and given that state, here's the data that we need, and here's the functions that you need, and then like, let me package all those and send them to the destination, the front end or whatever. In the long term, that's where I see like things going. What's nice about that is that we have very limited options right now when it comes to bundle splitting, right? Like you can imagine splitting it on a page by page basis, or you can just send everything to the front end, or you can manually kind of figure out what's in a separate bundle. But like in an app that's very dynamic and interactive and has a lot of different components, you don't want to send all the JavaScript that could ever be executed to the front end, or else like when you go to facebook.com, you'll download like 10 megabytes. And that's not good because, not every user is on a T1 connection. So one of the things that you would like to do is to only download the JavaScript that's actually needed by a given screen. And so, for example, with a newsfeed, you might imagine that you have a text newsfeed item, or you have a poll newsfeed item, or you have a video newsfeed item. And a given user, depending on what actually shows up in their newsfeed, might not need all the different types of JavaScript and should only download the JavaScript based upon the types of newsfeed items that they encounter. And that's basically a bundler. That's a bundler running, per request bundler that is running that says like, hey, given this, we need this. And Relay has data-driven dependencies with 3D, which does exactly what I just described. It like lets you download just the JavaScript for data types that you have encountered. So you'd only download the video player if you encountered a video newsfeed item, and so on and so forth. Like these are all, I guess, aspects of what in the long run is like, hey, the bundler should have enough information about the client state. And given that client state, it should know what requests to make to the backend. And given the results, it should know what functions to send down to the front end. And I think that's the primitive that the front end ecosystem is heading towards. And that's like the long-term vision for Isograph.
There's a lot of plans. I mean, we covered a lot of track today. It's really awesome to hear about Isograph. And as you're talking, I'm thinking to myself, I actually have ran into a lot of these problems. So Monday we have our Rust meetup, and I think I'm going to grab some people. And it's funny that we're doing this on Monday because actually we have two developers who work overseas, one in India, one in Africa. They're actually in Hong Kong as of today. So I'll probably be grabbing them to come to the event and maybe pull you aside and hear some more about, how this may be useful.
Amazing.
This is production ready though, right? We
I-
can actually start to use it.
Yeah, it's usable in some demos.
Okay.
There's no production users of it, but
Well, maybe this would be
Yeah.
the first kind, right?
Yeah,
So, because
exactly.
we are running into this problem, like the biggest issue we're running into is, keeping the queries in sync. We do end up changing data fields once in a while, and that's always hectic too. We have GraphQL queries sprung out all over the place. Having that way that we can kind of have like, top level one-time query for a whole page would be really nice to have.
Mhm.
So I'm looking forward to seeing what other people think, but it sounds great so far.
Yeah, I'm honestly like super excited about this, and I make a lot of progress every time I sit down and work on it. And honestly, I think in 6 months to a year, like this is going to be the best framework for building web apps and eventually for building cross-platform apps. And it's just going to be a no-brainer that Isograph is the way that people build things. So
Well,
Yeah.
let's see if that happens. So
Yeah.
again, thanks for coming in. Obviously, you're here on pleasure, but it's also good to have podcasts and hear more about this. Yeah, let's see if we can record the event or not. But otherwise, we'll be publishing this one soon, actually. So
Yeah, I mean, I recently published the same talk that I'm about to give at the Rust Tokyo. If you search for Isograph plus Tokyo, but not like the project, like the city in Japan, you'll find my presentation on building the Isograph compiler in Rust, in which I go into a lot of detail on the Rust aspects of it. Might be of interest to the podcast.
yeah, I'll probably try to
listeners.
link that one too.
Yeah.
That would be great. All right, thanks again for coming on. So maybe in another 6 months or a year, when you're more stable state, we'll probably bring you back on to talk about where things went. I can imagine things changing vastly from now till then.
Yeah, every time I have a deep discussion with somebody who's in the GraphQL space or is in the Rust space, like some aspect of the roadmap changes or gets, clarified. So I have no doubt that a year from now, like a lot of what I said will be slightly off. So
Awesome.
thank you